Good morning, boys and girls. We are working on Module 4, Lesson 13 today in geometry. And today we're going to analyze and classify triangles based on side length, angle measure, or both. Now behind me I've drawn a sample of triangles. There are 6 of them. And in your workbook, in Lesson 13, you have a template with each of these triangles that you can cut out. And if we were together, that's what we would be doing. So each one is specific and lettered A, B, C, D, E, or F. And also in each corner, they have a point that's labeled to them. See if you can see there's X and Z and Y. So that if you wanted to talk about their angle and their angle measures, you have points of reference to do that. So what we are specifically going to be talking about today is how to classify the angles and how to determine, based on their sides, their angles, how to do that. Now, granted, this triangle can be considered the same as this triangle, and let me explain why. First of all, sorry, there is no or. So if it contains one obtuse angle, it is an obtuse triangle. So here we have an acute triangle because all of the angles are acute. Here we have a right triangle because one of the angles is a right triangle. And here we have an obtuse triangle because one of the angles is obtuse. How about B? What would you classify B as? Acute, obtuse, or right? Triangle B would be an acute triangle because all 3 angles are acute. Triangle E down here in the corner, if we get our right angle template out and measure, we would see that, yep, that fits in that corner. So that one would be a right triangle. And then F up here appears to have one obtuse angle larger than 90 degrees and 2 acute, and that would make it an obtuse. So that's one way to classify a triangle. And what I was meaning with this one is, even though it's tiny compared to this one, it's still an acute triangle because it has 3 acute angles. It doesn't matter if it's as big as a house or if it's as small as a dime like this one. As long as all 3 angles are acute, it can be classified as an acute triangle. Now the next thing we're going to talk about, classification of triangles, is the sides. And by sides, I mean the length of the sides. If you take a look at A, it looks pretty even, doesn't it? If I take my straight edge and I measure, this side is 4 inches, this side is 4 inches, and this side is 4 inches. All 3 sides have the same measure. That is called an equilateral triangle. The sides are equal. Equilateral. Do I have another equilateral triangle up here? B kind of looks similar, but something's a little off, isn't it? Let's take a look at B. If I measure B, this side's 4.5 inches. This side is also 4.5 inches. But the bottom is only 3 inches. So in triangle B, I have 2 sides that are the same length and 1 side that is different. That is called an isosceles triangle. Isosceles triangle. So I have an equilateral an equilateral triangle, an isosceles triangle. And the way I denote, if I were to write this out, I would put, we did this, I think, briefly when we were doing lines. If I put what kind of looks like a weird twisted around, turned around equal sign around those sides, that tells me that those sides are equal. Now on this isosceles triangle, if I wanted to denote that, I would only put those equal signs on 2 sides. That shows me that they are equal. Now, On the other triangles, let's see, this one has a side of about 3 3/4. This one has a side of 2 3/4 and a side that is 6 inches long. None of those sides are equal. And when none of those sides are equal, that is called a scalene triangle. And I'm going to put these vocabulary words up for you in just a few minutes. So you can have an equilateral triangle where all 3 sides are equal. You can have an isosceles triangle where only 2 sides are equal. Or you can have a scalene triangle where none of the sides are equal. And now finally, we've talked about the sides, how to classify triangles based on their sides and the length of their sides. We've talked about how to talk about triangles in terms of what kind of angles they have. And the last, we kind of referred to it when we talked about a right angle being 90 degrees. And there's another particular way of thinking of triangles and their measurement or angle measurements. And so if triangle A has 3 equal sides, what do you think about those angles? What do you think might be true about those angles? Do you think those angles might also measure the same if these 3 sides are equal? Because we know that in a square, those 90-degree corners really, well, let's try it. Let's try it with the protractor. I'm going to go here to this corner, and I am going to put my protractor down, and I'm going to see that that measures right at about 60 degrees. And I'm going to take this angle, and I'm going to put it down, and I'm going to measure this one. And if I read my protractor, I see that one is 60 degrees. And if I take my protractor and measure this angle, I see that this one is also 60 degrees. So each of these angles inside of an equilateral triangle are 60 degrees. They are equal to one another. Pretty cool, right? Now, inside a scalene triangle, do you think that all of these angles are equal to one another? Well, first of all, they aren't, because we have 2 that are acute and 1 that's obtuse. So that's not going to work. And the same with a right angle. If a right angle, if this is 90 degrees, the other 2 cannot be 90 degrees, right? Otherwise it wouldn't be a triangle, it would be a square or a rectangle. Let's try this isosceles triangle. It's got 2 equal sides. So, do you think it's going to have 3 equal angle measures? No, probably not, because it doesn't look like that. So something's got to be different. So let's try and measure these angles. So down here, I am getting an angle measure of about 75. And in this corner, if I measure correctly, I also get an angle of about 75. And then if I do this angle up here, I get an angle measure of about 30 degrees. So I have 2 angles that match down in these corners, and then 1 that doesn't. So an isosceles triangle has 2 equal angles and 1 that is smaller. Okay, we are going to move on to our problem set, and that shouldn't take too long, and then you'll be done. Okay, I promised you I would put up the vocabulary, and I forgot. So, in terms of the sides, when we talk about the sides of a triangle, they are either equilateral, isosceles, or scalene. Equilateral meaning all sides equal, isosceles, 2 sides are equal, and scalene, no sides are equal. And then an acute triangle has all angles acute. A right triangle has 1 right angle. And an obtuse triangle has one obtuse angle. And now we'll do the problem set. Okay, here we are, lesson 13, problem set. Classify each triangle by its side lengths and angle measurements. Circle the correct names. So the first column is the triangle. This is classifying using their side lengths with that vocabulary right here. And then classifying using the angle measurements. And that vocabulary is right here. So, triangle A. I see 2 tick marks. They use 1 tick mark to show that those sides are equal. So this means that 2 of these sides are equal. So what kind of triangle is that? When 2 sides are equal, it is an isosceles triangle. Now, what about the angle measurements? If I look at this triangle, I see 2 acute and 1 obtuse. So that makes this an obtuse triangle. Take a look at B. Here I have 3 tick marks or equal marks. Each of these sides is equal, making this an equilateral triangle. And if I look at those angles, I see 3 acute angles. In triangle C, it's showing me that one of these angles is a right triangle. But if I look at the length, the side lengths, I see none of those sides are equal in length. And if you wanted to, you could check it with your straight edge or get out your protractor, and there's also a ruler on the bottom edge of that protractor. So if I check it that way, I see this is 1 1/4, this is 1 1/8, and this side is, looks like maybe 6/8 long. So none of those side lengths are equal, making this a scalene triangle. And if one of those angles is a right angle, that becomes a right triangle. And then here we have D. I have no tick marks, so that means none of those sides are equal. That makes this a scalene triangle. And I see I have 2 acute angles, 1 obtuse angle, making this an obtuse triangle. Now we did not talk about the symmetry in triangles, so we are going to skip 2 and 3. Okay, and we are going to go on to the next page with problem 4. In problem 4, use a ruler to connect points to form 2 other triangles. Use each point only once. None of the triangles may overlap. 1 or 2 points will be unused. Name and classify the 3 triangles below. The first one's done for you. So this person drew using points J, F, and K. They drew this triangle. So now take your ruler, your straight edge, or your protractor, and you draw 2 more triangles. So I'm going to use E, D, and A for one of them. And I, C, and H for my other. Okay, so now I have 2 triangles. I'm going to label them here with this symbol. So I have triangle C, I, H, and I have triangle A, D, E. Now, I have to classify each by its side length. So I'm going to take my ruler and I'm going to see that this is 2 inches long, this is 2 inches long, and this is 1 1/4 or 1 1/3 inches long. So I'm going to put a tick mark here because that's equal to this. So this A and E has 2 sides, ADE has 2 sides that are equal. That makes that an isosceles triangle. And then if I look at the angle measurements, they are 3